Okay, this is the second video out of 4 covering the last lecture on section 3.3. In this page here, we're going to talk about, we're going to develop basically it's called the general power rule. And so to kind of show you how it works, we're going to kind of derive it here in a real simple way. So just taking a look at here, this statement, use the information we've gained about applying the product rule to functions with multiple factors, which is what we just did on that page, the first page. It says using that to differentiate the following functions. And so our first function that's mentioned here is this d dx of f squared of x. Now, f squared of x. Of course, we don't know what f of x is. We don't know what the function is. We just know that it's a function and it is squared. And so to understand what that means, it's good to know this little hint over here that f squared of x, that's the same thing as f of x times f of x. So that should tell us something because that's basically applying the product rule. And so if I have two functions multiplied together, in this case the same function multiplied by itself, I can still use the product rule on that. So if this is the case, then I want to take the derivative of f squared of x. That's the same thing as taking f of x times f of x, and then taking the derivative of that. So, of course, from the product rule, we know that's going to be the derivative of the first function times the second. So f prime of x times f of x plus the derivative of the second function, which again is the same here, f prime of x times the first. And so you notice these are the same thing, just twice. It's written twice. So this would be equal to 2 f of x, if you will, f prime of x. Or I could write it, 2 f prime of x times f of x. But so this is the result of taking the derivative of f squared of x. So what we're going to do is we're going to do this for a couple more and then try to come up with a pattern here. All right, so this next one would be the derivative of f cubed of x. So that is just equal to what? F of x times f of x times f of x. And then we're taking the derivative of that. And so that's going to be, well, of course, using that, extending the use of the product rule for 3 factors. So this would be f prime of x times f of x times f of x. And then add on to that. Remember, move the prime down the line. So this would be f of x times f prime of x times f of x. And then lastly would be move the prime down to the last one. So f of x times f of x times f prime of x. And so what you see is here, to simplify this has 2 of the f of x's multiplied together, and here's 2 of them that can be multiplied together, and then here's 2 of them. So that's really f of x squared, right? So this is, if this simplifies this first term to f squared of x times f prime of x, and so do all the others. This f of x times this f of x gives us an f squared of x, f prime of x, and then lastly the same thing, f squared of x times f prime of x. And so you see we have 3 of those, right? And so this will be simplified as 3 f squared of x f prime of x. So that's the result of taking the derivative of some function cubed. All right. Lastly, before we kind of come up with our our formula for this general power rule, so this is derivative of some function raised to the fourth power. And again, this f of x stands for any function. So we're trying to come up with this generalized rule for taking the derivative of the power of some function. So this would be the same thing as when we're taking the derivative of f of x times f of x times f of x times f of x. And we're taking the derivative of that. So you know what we're going to do is we're going to move the prime down the line, and we're going to have to do that 4 times, right? So just to save a little time here, when you do that, we're going to end up with this f cubed of x, f prime of x, and we're going to have that 4 times. F cubed. Oops, sorry, didn't mean to prime that. So this would be f cubed of x, f prime of x, plus f cubed of x times f prime of x, and then one last time would be f cubed of x times f prime of x. And so we have what? 4 of those, right? 4 groupings of those. So this would be 4 f cubed of x, f prime of x. And so you can start to see a pattern here, right? That when we were taking f of x and raising it to the 4th power, that now what's left is the 4 comes down in front of the function, and then what's left with the function power is it's 1 less. And then we always have the f prime. So here's the general power rule whenever we want to raise a function to a power. All right. So this is going to be, so if we're taking a function f and raising it to the nth power and taking the derivative of that, that's going to be n times f of x to the n minus 1 power, and then times f prime of x. Okay. Now that's different from taking the power of taking using the what we call the power rule for a polynomial, right? Because before, when we were doing that, let's say if you had 6x squared and we wanted to take the derivative of that, that was going to be, you multiply it, you take the power down and you multiply it, so it'd be 12x, and this 2 is 1 less than that, so that'd be x to the 1st power. So this is different in that what we're doing here is we're taking an entire function and priming it here, no matter what the function is. So the result of that is not only that n is moved down in front and this function is taken to the n minus 1, but we're also multiplying by the derivative. So let's see an example of this right down here. We'll just do one real quick. So here we have the function 3x squared plus 4x, and then that is raised to the 3rd power, right? So here is basically our f of x, our f, if you will, and it's raised to the 3rd power. Okay, so that's what we have. So this applies. This would be like f of n to the x, except for we're doing f of 3 to the x. So how is this going to work with our formula here that we have for the general power rule? Well, it says we should take the exponent 3, bring it down in front, so it's going to be 3, and then it's f of x to the n minus 1, so our f of x is this 3x squared plus 4x, right, and then that's to the n minus 1, so n was 3, so now this is 2, and then we're going to multiply that by the derivative of f of x. So let me just write that down. It'll be 3x squared plus 4x prime. Oops, sorry. Yes, 4 x prime. Right, so just one other step here. I'm just going to copy these down here and then take the derivative of 3x squared plus 4x. And so that would be what, 6x plus 4. And then you would want to multiply the rest of that out, but that just demonstrates the use of the power rule, and then the rest of it's just algebra multiplying all that out. Okay. So this this second page was just all about coming up with and deriving and explaining how to use this general power rule when you want to take the derivative of any function to any power.